Assalamualaikum. We are from the group 3. We'll do the video presentation of the Boscan field, Venezuela. Before we start in deeper, we have to start at the general information, which is we start at the location of the Boscan field, which is at 45 kilometers southwest of Maracaibo, Venezuela. First, it was discovered in 1946 by Jafrel with drilling of the Zulia 7F1 well, which tested produced 730 barrels per day. And right now, the company that operated the field is Empresa Mixta Boscan, and it was joint venture with the Petroleum de Venezuela and also Chevron. Boscan field has produced over 1.6 billion barrels of oil, less than 6% of productions of oil in place. It was 950 well oil drilled and approximately 525 active wells. It is said that 1.6 billion barrels of proven is reserved, and right now it is priced around $40 to $41 per barrel. And this value, we can conclude that the price of the reserve productions is about 64 to 65.6 billion estimated. Thank you.
My name is Muhamad Amal, and we will explain about regional tectonic setting at the Boscan field. The basin type in the Boscan field is known as the Maracaibo Basin. It is known as the Lake of Maracaibo. Maracaibo Basin is a foreland basin and one of the 8 natural regions of Venezuela that found in the northwestern corner of Venezuela in South America. It covers over 36,657 square kilometers, which is a hydrocarbon-rich region that has produced over 30 billion barrels of oil. The basin is characterized by a large, shallow tidal estuary, Lake Maracaibo, located near its center. The Maracaibo Basin has a complex tectonic history. Despite its complexity, these major tectonic stages are well preserved within its stratigraphy. This makes the Boscan field one of the most valuable basins for the reconstructing South American history of tectonic history. The formation of the Maracaibo Basin began over 160 million years ago. This formation includes the North American, South American, and Caribbean plates that playing key roles in the evolution of the basin. It developed into the present-day foreland basin by multiple stages throughout time. It includes late Jurassic, late Cretaceous, Paleocene, Eocene, and the Oligocene, Holocene stages. During Jurassic stage, the North American plate began to separate from the South American plate during the breakup of Pangea. The two plates rifted away from each other and forming the Proto-Caribbean Seaway. As the rifting occurred, the Caribbean plate began its eastward migration from the Pacific region. For the late Cretaceous stage, the northern edge of the South American plate developed into a passive margin with the Proto-Caribbean Seaway after rifting. Then, for the Paleocene-Eocene stage, the Caribbean plate has been migrating eastward from the Pacific region and eventually collide with the South American plate in the Middle Paleocene. This collision transformed the passive margin of northern South America into an active margin. The Caribbean plate had subducted significant amount of oceanic Proto-Caribbean crust by the time and was now subducting beneath the South American crust. And the last stage is the Oligocene-Holocene. The Caribbean plate continued its migration toward east and continued to deform the northwestern region of South America. It also producing deformation along the northern eastern region. The main event of sediment deposit follow the same pattern as the tectonic event, where major sedimentary flow occur simultaneously with the 4 tectonic stages earlier. The thickness difference is related to the greater or lesser subsidence that allow the variation in the sedimentation. The interval measure of the Boscan field is about 1,750 feet in about 530 meters in thickness.
Assalamualaikum and hi, my name is Mior Ikram bin Malik TH18032. In this video, I will be presenting about the petroleum system elements of the Boscan field. There are 4 types of petroleum system elements. The first is the source rocks. The source rock is very important because it contains plenty of organic material. The edges of the source rock of the Boscan field, it is in the Oligocene to and Eocene edges. It is in the Paleogene period. The types of rock that we can find in the source rock of the Boscan field is the shale and limestone. Next is reservoir rock. Reservoir rock is the rock that providing a condition to trap oil in porous media. The edges of the reservoir rock of the Boscan field is the same with the source rock. It is in the Paleogene period. Next ratio, reservoir net sand to ghosting is 70% to 80%. The sand porosity of the Boscan field is 10% to 20%, and the sand permeability of the Boscan field is 100 to 5,000 millidarcy. Okay, the third is the seal rock. The seal rock is the impermeable rock that form a barrier above the reservoir rock. In the Boscan field, the seal rock begin with the colon shell that overlies the La Luna formation and form a regional seal over the Maracaibo basin. Okay, the last is the overburden rocks. Overburden rocks is the type of rocks that overlies the source rock, seal rocks, and reservoir rocks. The thickness of the overburden rocks can provide a history and the edges of the source rock. For the Boscan field, it has a high thickness of the overburden rock. It is because of the combination of the fluvio-deltite and deltite sedimentation resulted in the thickness of the Eocene and cover the whole basin.
Next is the petroleum system processes. The Boscan field is produced from a structural stratigraphic trap that formed by a combination of faulting and the truncation and phases change of upper Eocene and lower Oligocene sandstone. The field is a combination of stratigraphic structural trap that is monoclinal with southern dip and a strike-slip Boscan fault to the east. It is formed as a result of changes in the structure of the subsurface due to the tectonic, diaphoric, gravitational, and compaction processes. The Boscan field is a large stratigraphic trap that are generally from fluvial deltite clastic reservoir. These are folded, and are truncated by pre-Oligocene unconformity. There is also significant production from Oligocene fluvial sandstones lying open the paleotopography of the unconformable surface. The maturation, migration, and trapping of hydrocarbon were closely controlled by the tectonic evolution of Boscan field. Hydrocarbon migrated up deep from source rocks beneath the northeastern margin of the basin along north-south strike-slip fault and into overlying Eocene clastic reservoir in the south-central part of the basin. Based on organic, geochemical, and sediment logical characteristic, it is proposed that primary migration of oil from the Boscan field source rock took place by expulsion of hydrocarbons. The migration is through the bundle of microfracture that developed by the pore fluid overpressure during hydrocarbon generation.
My name is Muhamad Arif Zakaria bin Muhammad Sukri. So today I will present my part, which is conclusion for our mini project. So as a conclusion, the Boscan field is a large field that produces crude oil with 9.5 to 12 API gravity and a viscosity of 130 to 500 cp, depend on their temperature to the reservoir depth. The 175 farad, equivalent to 79.4 Celsius reservoir, consists of basal Oligocene sandstone above and upper Eocene sandstone below. Boscan field is a sandstone and produce mainly heavy oil with an asphaltene content of 17.2%, attributed the differences to the lower stability of asphaltene in lighter crude oil in Mata Asema field. The formation is at a depth of about 2,600 meter and a bottom hole temperature of 180 farad, equivalent to 82 Celsius. The importance of this field lies in the fact that it is one of the largest proven heavy oil reservoir in Venezuela, containing about 17.2 asphaltene, and until now, no asphaltene deposition problem has been reported. It can be observed that the Mata Asema crude with asphaltene content of only 0.4 to 9.8% have asphaltene deposition problem, whereas the Boscan crude with 17.2% asphaltene content does not have asphaltene deposition problem. Boscan crude and Boscan refined oils, which include a lot of peptizing agents such as resins, were found to prevent electrodeposition of asphaltene from Mata Asema crude and also asphalt precipitation when mixing acid and mata air macro.